Hello, good morning. Calculus 1. I want to help you with this one problem in section 2.5. So there's this truck driver problem. It's number 64. I think I assigned it in your homework, and I thought I'd help you with it. So here's what they say. The truck driver leaves this place and goes to this place. So it's a distance D. So that's it. And on the way there, the average speed is X. Okay. On the return trip, on the way back, same distance, D, the average speed is Y. So that's it. Then they tell us one other piece of information. The average speed for the round trip, the whole trip, was 50 miles per hour. So I've got this unknown speed on the way there, this unknown speed on the way back, same distance. And then the round trip was, I got the average speed for the round trip. So 50 miles per hour. And then they say this, they say the relationship between Y and X, which are your two different speeds, is this. And they want me to verify that. So I have to prove that. So that's cool. I think I can do that. I practiced this problem. So the idea is, distance equals rate times time. That's a big idea in a lot of problems. I think we've addressed it in another problem. It's going to help me here. So I wrote that three different ways here, sorry. Distance equals rate times time, D equals RT, or small d equals lowercase or uppercase, however you want to do it. So here I go. On the way there, I don't know the D. I just got some distance D. And I do have my rate. My average speed is my rate, so my rate was X. And I don't really know the time it took either. I don't know the time it took to get there. Nobody mentioned time. Okay, what about on the way back? On the way back, it is the same D. It is the same distance D, but it's a new speed, Y. That's my rate. And it's again, it's an unknown time. Now here's the interesting thing. It's the same distance, and those two times I don't know those times, but they're not the same. I can't just leave it T and T because they are different times. If you're traveling at different average speeds, I think you'll accomplish this distance in a different time. So I'm calling this one a T1 and this one a T2. They are different times. Okay. Same distance, different rates of speed. X and Y. All right. So I can write that stuff down, and I can do some algebra here in a minute. This is an algebra game. But let me write down one more thing. The average speed for the whole trip was 50 miles an hour. So I'm going to write this down. Let's see, what was the whole trip? The distance for the whole trip was there and back. So that's there and back again. That's 2D. That's the distance for the whole trip. The speed was 50 miles per hour for the whole trip, 50. And what was the time? And the time on the way there was T1. The time on the way back was T2. So I think the time for the whole trip is T1 plus T2. So there you go. And now I can do some algebra and derive this equation. Now the way your WebAssign homework does it, they kind of guide you through it, and they start with, I don't know, they start a little different here. But here's what I want to do. I don't know a thing about time, and so I want to solve for time and substitute it in for this time. So what is T1? T1 is D over X, right? If you divide by X, D over X is the time T1. What about T2? T2 is D over Y, and I could substitute those into that equation. So 2D equals 50 times D over X plus D over Y. And I could proceed from here. Like I said, I think now that I'm thinking about it, I think your WebAssign guides you through this, and they do it a little differently. But I think I've discovered the easiest way to do it, sorry to say, or happy to say. how about this? Can I just, well, let's factor a d out of that. I would have this 2d on this side, and I'm going to factor a d out. If I factor a d out of those two terms, I have 1 over x and 1 over y. And maybe now you can see that you can cancel a d. Not only can you cancel a d, you could divide by 2 if you want to. So if you don't mind, can I divide by 2d? Can I divide by 2d? This turns into a 1, and this turns into 25. And the d is really what I was trying to cancel. I also decided to divide by 2. But I just canceled those d's away, and now I have this. And maybe you remember from algebra, if you got a bunch of denominators and you want to get rid of these denominators, you should multiply by the common denominator. So I think my next algebra step is multiply by xy. xy. Multiply both sides of this equation by xy. If I multiply this 1 by xy, it's xy. If I multiply this by xy and I distribute it through, if I multiply, taking xy and distributing it through, xy times this, the x's cancel and leave me a y. xy times this, the y's cancel and leave me an x. Maybe you need to write that out a little cleaner, but that's what just happened. I multiplied both sides by xy. Okay, this is awesome. We're getting close to the end here. If I distribute that, that's 25y and 25x. If I get these y's over here on the same side together, that would be xy minus 25y equals 25x. I'm going to move over here if you don't mind. I will factor out a y, and I'll have x minus 25 equals 25x. Okay, over here on the left-hand side, I factored out a y. Now you can divide by it, and you see where we are. 25x over x minus 25. So we did derive their equation. They wanted me to verify that, and we found that's the relationship between y and x in this truck driver problem. So that was the first part of the problem. The next part of the problem wants me to build a chart and plot some values. So again, this is very algebraic, very pre-calculus. I'm going to get rid of some of this, so I'm going to erase some of these ideas. They want me to build a little chart and plot some values for different values of x and y. They suggested 30, 40, 50, 60. So that's kind of fun to see the relationship between x and y. I mean, if you average 30 miles an hour on the way there, then what do you have to, what's y? On the way back, what do you have to average? Keep in mind, the round trip average is 50 miles an hour. So if you're only going 30 on the way there, you probably got to really speed on the way back. If you're going 40 on the way there, y is probably a little less. If you go 50 on the way there, that might be 50 on the way back. That might make sense. If you go 60 on the way there. So anyway, here's our formula. I can plug these numbers into this formula and see what I get. I can do the math. I can use a calculator. If I plug in a 30 into this formula, here I go, 25 times 30 divided by, if I plug in a 30 here, that's going to be a 5. That's pretty easy. That's 150. Yeah, like I said. Wow, if you only go 30 on the way there, you got to go 150 on the way back. That's interesting. You took a lot of time to get there. What if you go 40 on the way there? 25 times 40 and divide by, if I plug in a 40, I divide by 15, 66.666, 66.7 miles per hour. That's what I have to drive on the way back. What if I go 50 on the way there? What's 25 times 50 over 50 minus 25? I just did it in my head. It is a 50. What if I went 60 for x? 25 times 60 divided by 60 minus 25 is 35. That's 42.8, 42.9 miles per hour. Yeah, okay, there you go. That's interesting. If you drew a picture of this, let's see what we got going here. You know, we could graph this function using a graphing calculator, but I did just plot a lot of points. One thing I know about this function is it's undefined at 25. And so at 25 must be a vertical asymptote. Oh, that's interesting. And as you approach a vertical asymptote, you head toward infinity. Oh, that's kind of what this did. I mean, when x was 30, the y was 150. It's not quite infinity, but I think I get the point. You know, what if x was 29, 28, 26, I think y would be very huge. I see what's going on. Yeah. If x is 40, y was 66.7. If x was 50, y was 50. So what's the question? The next question is, find the value of y as x approaches 25 from the right. Well, we just did that. We did it visually, graphically. They also say interpret the meaning, but find the value of y as x approaches 25 from the right. We've done those kind of limits here in section 2.5. I think that it looks like the answer is infinity. And what does that mean? Interpret the meaning. Oh boy. You know, there comes a point where you can't average 25. You know, average 50. You know, if your speed on the way there was less than 25, I don't even think, or 25, you can't even get to an average of 50. To get to an average of 50, that x has got to be greater than 25. And it should be a lot greater than 25, but if it's just slightly greater than 25, if x is slightly greater than 25, then your speed on the return trip has got to be huge. So that's what this means. In order to average 50. Man, that's a good problem. I like problems like that. In a way, they're not that hard. I mean, I did some algebra at the beginning that some students would call difficult, I suppose. But try to do it. Good luck.